good? How are you doing?
Mr. Peterson, this is
okay, so we have a bell jar, we have a balloon, and we have a base. Okay, we put that in. We have the syringe like this. Everybody correct?
Yes.
All you have to do to attach is take the long end, then twist it so it's going to stick. Okay, so it should all be one apparatus now. Okay, so Cosmo, hold this. So the person that's holding is going to make sure the base stays in one spot, and all the other person's going to do is make sure you zoom in on this. You got it? Okay, pull out the syringe. Okay, what's happening to the balloon? Okay, so now you can let go. Okay, so do that. While you're doing that, you need to discuss why is this happening and what concept does this show. After a while, everybody look up here. When you, that's fine if you do that. Just push it back in. Okay, but don't do that on purpose, otherwise I'm taking it away. Okay, after you do that, watch what happens. Everybody look. Everybody look up here. Are you looking? Okay, watch what happens when I do this. Oh. Alright, okay, cut it. Go back, have a good day. Alright, okay. Let me see your answers. Hold them up. 1, 2, 3, hold up. Boom, 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 boom. I don't see this. What does yours say? Oh, wow, what's that called? The answer is, if you have Boyle's Law, you get 1 point. Wait, I have to see an explanation. So 1 point over here. Let me see what you have written down for Boyle's Law. Boyle's Law, when you read out loud.
When you pump the air out, it cranks less volume.
Okay, so everybody look up here and be quiet because we're videotaping now, so we got that good. I have this balloon that is filled with this much. When I'm using this and pulling, it's pulling air out. The reason we have to use this apparatus is when we push the air back in, this is a one-way valve, so all the air that we push goes out this way, so it doesn't actually go in there. So we're actually only taking air out. When we take air out, does that mean there's less air pressure in there? Yes, which means there's less chance of that balloon or less things pushing in on that balloon. And then when I open it back up, what happens? The air goes rushing back in, it puts pressure back on it, so then it deflates. Okay? So this is a reason why like those lights can work, because we can make things change states by making their particles speed up by pressure. Because are the particles in this balloon going faster when they're like this, or when they're like this? When they're nice and pumped. Which one are the particles moving faster in? Pumped, okay? Because they have more space, they're going crazy, they're not getting pushed as much. Alright, welcome back. Yeah. Professor Redmond wanted to say hi. Sorry. Don't go blind. Don't work on it. Okay. Alright, now right here I have, hopefully I don't burn myself like last time, I have 1 pot of boiling water, 1 pot, an Erlenmeyer flask for some boiling. What I'm going to do is I'm going to take a regular balloon and I'm going to make it do this. And we're going to explain why is that happening. Okay? And if you've seen it before, awesome, good for you. Alright? So the first thing I'm going to do is I'm going to take this Erlenmeyer flask, and I will burn myself, so don't laugh too hard. Okay? Hopefully I won't burn myself as bad as I did in the second hour. Is that really hurt? Okay? So, here we go. Take this. I'm pouring the water out, and I'm going to put a balloon on top. It's going to hurt.
We have like safety gloves. Nathan, move your head. Daniel, move your head.
Bigger balloon. Just do it 1 time.
It's not about me. It's not about me. Gosh, first hour I did it first try and it felt awesome.
Teach us science.
We're going to start over because I need more. Okay, alright, so we're going to... Sorry, we need a quick pause. Alright, I have this. No, you don't. Okay. Alright, I have this. Okay. Hold that. Okay. This is a bed of nail. Professor Berger is going to sit on this one. Okay. Pull this. Come on.
Nathan, move your head.
Gotta want it. There we go. And this is a bed of nails. Professor Tuttle's going to sit on this one, okay? Right. Here, just so everybody knows, feel it, just see if they're sharp. Are they sharp? What you feeling? Are they sharp? Yeah, okay, they're sharp. Okay? Alright, so what we're going to do is we're going to... I'm not going to make you test it. I'm going to blow up a balloon, and we're going to use the different beds of nails, or bed of nail, and see what happens, okay? Alright, there we go.
It's like a science
Here's the
clown.
balloon.
Mr. Peterson, you're being a science clown today. You're blowing up.
Alright.
You're blowing up.
Shut up. Okay. Here we go. We're going to get this set up. So, there we go. Okay. Alright. Okay, now, it popped. Yes, it did. Okay. But, did it pop right away?
No.
So let's see what happens. To make this a controlled experiment, I'm going to use the same colored balloon. Because I can't use the same balloon anymore. Try and make it about the same size. Okay. Alright. And then now I'm going to put it on the bed of nail. Okay.
Forward so we can see it.
Oh, I'm sorry.
Thank you, Mr. Peterson.
Okay, here we go. Alright. Did that one pop right away?
Yeah.
Okay. So then now, talk to your group, figure out why that happened. Okay.